Hurricanes, a force of nature. Hurricanes are amazing natural spectacles. These super strong storms form over warm, tropical oceans. The water's heat and energy enable hurricanes to grow into giant, spinning storms. Hurricanes contain heavy rains, clouds, and dangerous thunderstorms. Strong winds blow at more than 74 miles an hour. These winds create powerful storm surges. During a storm surge, the surface of the sea pushes up quickly. The sea can rise as much as 20 feet. Not all hurricanes reach land, but when they do, watch out. Hurricanes can be very dangerous. When Hurricane Michael hit the panhandle of Florida in 2018, it destroyed everything in its path. Heavy rains caused flooding, while storm surges flooded coastal areas and destroyed roads. Fierce winds toppled trees and destroyed buildings. Flying debris from these buildings caused more damage. More than 40 people perished. Photo of hurricane off the coast of Florida, taken from space. Hurricane Michael destroyed boats and docks in Panama City, Florida. Hunting hurricanes. Meteorologists are scientists who study the atmosphere. These scientists have studied hurricanes for decades. They know that the center, or eye, of these storms is calm and cloudless. Around this circular eye is the eye wall, which contains the heaviest rains, strongest winds, and thickest clouds. This is the most dangerous part of the hurricane. On the hurricane's outer edges are rain bands. These bands bring intermittent rain and winds before the arrival of the storm. Surge. If there is a surge of water, there is a sudden, large increase in its depth. Debris. Debris is the pieces of something that was broken or destroyed. Perished. When people or animals perished, they died. Categories of hurricanes. Meteorologists use the Saffir-Simpson Hurricane Wind Scale. Storms that are categorized at 3 or higher are considered major hurricanes. Category 1. Sustained winds, 74 to 95 miles per hour, 119 to 153 kilometers per hour. Damage expected from winds. Strongly built homes can sustain damage to roofs. Large tree branches will snap. Damage to power lines will cause power outages that last for a few days. Category 2. Sustained winds, 96 to 110 miles per hour, 154 to 177 kilometers per hour. Damage expected from winds. Homes can sustain major damage. Many shallow-rooted trees will be uprooted and can block roads. Almost total power loss can occur and can last from days to weeks. Category 3. Sustained winds, 111 to 129 miles per hour, 178 to 208 kilometers per hour. Damage expected from winds. Strongly built homes can sustain serious damage. Many larger trees will be snapped or uprooted. Power and water will be unavailable for several weeks. Category 4. Sustained winds, 130 to 156 miles per hour, 209 to 251 kilometers per hour. Damage expected from winds. Strongly built homes will sustain severe damage. fallen trees and power poles will block roads, isolating residential areas. Power outages can last from weeks to months. Category 5. Sustained winds. 157 miles per hour or higher. 252 kilometers per hour or higher. Damage expected from winds. A large percentage of homes will be destroyed. Most of the area will not be habitable for weeks or months. Several important tools help scientists study hurricanes. Radar sends out radio waves in all directions. If the waves hit an object, they bounce back to the radar station. In 1957, a radar network first identified hurricanes near the United States coastline. Now scientists use an improved system to estimate the amount of wind and rain inside a hurricane. Weather satellites also help scientists learn about hurricanes. As these satellites orbit around Earth, they collect valuable information. In 2017, a new kind of weather satellite was introduced. This satellite can see the eye and eye wall of a hurricane from space. Since 1942, special planes have flown directly into these storms. The daring pilots of these planes and the scientists on board are called hurricane hunters. What are the wind speed, temperature, and rain like inside these storms? Hurricane hunters use special instruments to find out. One instrument, the dropsond, is a set of instruments with a parachute attached. As the dropsond falls, it measures data such as wind speed and air pressure and sends the information back to the plane. During an 8-hour flight, about 20 to 30 dropsonds are released in different locations. As they fall to the ocean, each one records data. The scientists use the data to build a picture of the hurricane. Flying through the eye wall of a hurricane is a bumpy experience. Wind currents push the plane up and down. But flying through the eye of a hurricane is calm and beautiful. No sound is audible except for the plane's engines. Pilots and scientists can see a circle of blue sky directly above the plane. The important information collected by radar, satellite, and hurricane hunters is sent to powerful computers. Then weather forecasters use it to make their predictions. Will a hurricane become stronger or weaker? Where and when will it hit land? The answers can help people better prepare for the storm ahead. First-hand account. Flying into a hurricane. Shirley Murillo is a research meteorologist at the National Oceanic and Atmospheric Administration's, NOAA, Hurricane Research Division in Miami, Florida. As part of her job, she gets to fly directly into the storms she studies. In this interview, Murillo discusses what it's like to fly into the eye of a Category 5 hurricane and how she first became interested in researching weather. What is flying into the eye of a hurricane like? It's a once-in-a-lifetime experience. Flying into a hurricane can be turbulent at times. You feel like you're on a roller coaster for 10 hours. I have flown in a variety of storms, from tropical storms that have wind speeds in the range of 34 to 63 knots, 39 to 73 miles per hour, to powerful Category 5 hurricanes with wind speeds that exceed 136 knots, 156 miles per hour. A lot of people have the misconception that we fly above the storms, but we actually fly into the thick of them, about 10,000 to 12,000 feet above sea level. The most turbulence is experienced in the eye wall. The eye wall is a ring or band of strong, deep, convective clouds that surround the eye the center of a hurricane. The highest wind speeds are found in the eye wall. Once you go through the eye wall to the eye, the storm's center, it can be fairly calm. It's an amazing sight to see. It's almost like being in the center of a football stadium where the seats surrounding you are made out of clouds. At the same time, you look above and you can see the bluest color of sky. If you look below, you see the ocean roiling with huge waves crashing. While I've flown into numerous storms, usually a few each year, I always have a sense of excitement and curiosity about how the storm is changing and evolving while we're in there collecting data. Shirley Murillo in her seat, ready to take on a hurricane. Why do you fly into hurricanes when radars and satellites already give us images of the storm? There's nothing that can replace the type of data that we gather straight from the storm. During our 8-hour-long flights, we have several flight patterns that we follow to collect various data sets. We're also dropping an instrument called the GPS Dropwind Sonde, also called a dropsonde, throughout the storm, and even in the eye. This instrument gives us a 3D vertical profile of the storm. This includes its temperature, wind speed, wind direction, humidity, pressure, and location every half second. The data is transmitted instantaneously from the GPS Dropwind Sonde to the aircraft where I process the data and quality control it. This information shows us what's going on inside the storm and how it's changing or intensifying. The data is transmitted via satellite to the National Hurricane Center and other NOAA agencies. They use the data in their computer forecast models to improve track and intensity predictions for the hurricanes. The data that we collect during these flights often play a critical role in helping hurricane forecasters to produce accurate and timely warnings. These warnings can save lives and reduce property losses. Hurricane hunters fly planes like these into the dangerous storms. Dropsondes, like the one above, are dropped from a hurricane hunter's plane to collect data. The data we've gathered have certainly improved our understanding of the structure of storms. Over the course of a single flight, we can see how quickly the storm evolves in a matter of hours. As we fly back and forth through the eye, we can track the pressure dropping and the storm intensifying. You may think you know what the storm is doing, but when you sample it, you discover it's a whole different animal. How did you first become interested in hurricanes and meteorology? It all began with Hurricane Andrew in 1992. It was the first storm I ever experienced firsthand. I was young, and I tracked the storm from my home in Florida. Fortunately, my family and I didn't experience the strongest winds and rain, so there was not much damage afterward. Once the electricity came back on, and we watched the news, I was really struck by all the images of destruction in southern Florida caused by the Category 5 storm. I was intrigued by the strength and power that nature can hold. Hurricane hunters, like Murillo, help keep people in the path of a hurricane informed and safe.